these are your Chapter 1 notes for statistics. So Chapter 1 is an introduction to statistics. 1.1 is statistical and critical thinking. Statistics is a science of collecting, organizing, summarizing, and analyzing information, which is our data, to draw conclusions. It also provides a measure of confidence to any conclusion that we might have. So why do we need or use statistics? So we use statistics, you'll notice it in a lot of different areas such as sports or maybe in medicine, but there's a lot of different statistics that you can collect even on YouTube video views and other online resources too. And this helps us predict things that are going to happen or where we need to maybe how a player is going to play or a team is going to do. But there's a lot of things that we can get out of the statistics in analyzing our data. So if you do not like mathematics, this is a different course for you. So statistics is a math course, but it's definitely different than just an algebra or any other kind of class that was mathematics that you might have had it previously. So in math, you would be given something like 2x minus 1, and you would have to solve it, and you would get an exact answer, and you would check your answer in the back of the book, and that would be it. So what's different is with statistics, we conduct a study, draw a conclusion, we place a level of confidence on this, and we're never going to be 100% confident about it. We might be 90% confident, and we'll get into why later, but there are issues where we might have errors. So something to be aware of. This is also going to be a lot of writing in this course, which is different than for math. So we have some vocab here. So the first thing is that with our vocab, we have population, which is an entire group that's being studied. So this would be like all the students at Mount SAC. And then we have individuals, and this is going to be a person or an object that is a member of the population that's being studied. We have a sample, which is a subset, so maybe just the students that are in our class. And then we have what's called a census, and this is an attempt to collect data from the whole population. They try to do this every 10 years. We have data, which is the collection of observations. Datum is a single data value. Sampling method is the procedure used to decide which individuals would be included in the sample, how they are picked from the population. So we have an example right here, and so you'll notice that throughout the notes we'll be adding things to them, or there'll be examples for us to fill in. So you're just going to fill them in exactly as we do in class or in this video. And so the example says fill in the blanks. It says the blank is the collection of all cars owned by all faculty. And then the second blank says a blank is a subset of the population, say cars owned by the math department. So the difference between these two is going to be that the first one is all faculty, and since we're dealing with all faculty, this is going to be our population. And then since the second one says that it's a subset or just this smaller group, which is just the math department, that's going to be our sample. So the next part down here below is just almost like an overview of what's going to be going on this semester. So the process involved in statistical studies is going to be prepare, analyze, and conclude. And so we'll be going more in depth on all of this throughout the semester. Right below this, we have what says voluntary response sample. This is going to be a self-selected sample. This is a sample in which the respondents themselves decide whether to be included. And then we have what's called statistically significant, and this is going to be when a result is unlikely to occur by chance. And so our key thing here, and you'll notice this a lot throughout the semester, is going to be 5% or less. And then we have what's called practical significance, which is going to be the difference between the samples is big enough to have any real meaning. So we have pitfalls to analyzing data, and so correlation does not imply causation. Sometimes our sample data reported is not measured or not measured correctly. Loaded questions, maybe how they're worded or the order of a question. So we also have issues with non-response where people don't respond or answer everything. And then we also have issues with percents, with errors in calculating those. So the example right below is dealing with percents. And so this involves converting percents to decimals and vice versa and using those. So in this course, we're able to use a calculator 100% of the time. So with that said, when you use a calculator, you're unable to put a percent in as a percent. You have to convert it to a decimal. So the first one on here says to convert 34.7% to a decimal. So to do this, we're just going to move our decimal point twice to the left. And so this is going to become 0.347. And this is what you would need to enter into your calculator to do any kind of calculations. The next one that we have is 6% of 1,200. So 6%, this again we would have to change to a decimal. And so I'll write it up here, but 6%, the decimal point would be right after that 6. So again, moving our decimal point twice to the left. This is now going to become 0. And there's nothing here, so we put a 0. So this is going to become 0.06. And then it says the word of here means to multiply. And so we're going to say 0.06 times the 1200. And so on your calculator, you would just type that in and do 0.06 times 1200. When you do this, and make sure to try this on your own, see if you get the answer of 72. The next one that we have says to convert 2/5 to a percent. So in order to do this on your calculator, you're going to do 2 divided by 5. When you do this, you should get an answer of 0.40. And it does want it as a percent. So we are now going to have to change this to a percent. In order to do this, we're going to move our decimal point instead of to the left twice like we did above. We are going to move it the opposite direction. So we're going to go right twice. So 1, 2. And then we need to add that percent symbol. So the next example says convert 0.892 to a percent. So the same idea. We're going to move our decimal point twice to the right. And so we're going to get 89.2. And then don't forget to add your percent symbol. The example says determine what is wrong with the example. Part A says in the USA Today online poll, 951 internet users chose to respond, and 57% of them said that they preferred drinking bottled water instead of tap water. So it wants us to know what's wrong with this. So the first thing is going to be that it was a voluntary response. And so this does not accurately represent our population since some people chose not to respond. And so then the next one, B, says in recent years, there has been a strong correlation between per capita consumption of sour cream and the number of motorcycle riders killed in a non-collision accident. Therefore, consumption of sour cream causes motorcycle fatalities. So this is a really extreme case, wanting you guys to see this use of these words here. And we know that sour cream and motorcycle accidents are not related at all. But the key word that they used in here is causes. And so just because there's some kind of relationship here, which is some kind of association, it does not mean that it causes anything to happen. So just because there's an association between things, it does not cause anything to happen. So association does not imply causation. So those are some errors with examples. The next example below says USA Today reported results from a Research Now for Keurig survey in which 1,458 men, 1,543 women were asked this question. In a typical week, how often can you kick back and relax? So part A says among the women, 19% reported rarely if ever. What is the exact value? That is 19% of the number of women surveyed. So really quick, we are only talking about the women, and it's 19% responded, rarely if ever. And so how many women were in our study? If you look up above, it's 1,543. So we're going to do the 1,543. And it does say this percent. So to figure out the percent, the number of those women that we would have, we have to multiply by that percent, which is 19%, which remember, move your decimal point twice to the left, and we get 0.19. So you would just substitute these both into your calculator and do 1543 times 0.19. You can include those parentheses or you don't need to. They should both work fine on your calculator. But when you do this, you get 293.17 women. Sometimes they'll ask you to round these values. If you were asked to round, this would round to 293 women. So B says among the men who responded, 219 of them responded with rare if ever. What is the percentage of men who responded with rare if ever? So this time it's asking for us to find the percentage, whereas in part A it did give us that percent. So for this one we're going to have a total number of 1,458 men, and I'm going to put that in my denominator since that's my total amount of people that were being asked this question. And then in the numerator, in the top value, I'm going to put how many people responded with rare if ever, which was that 219. So on your calculator, you type the first number, which is that top number, divided by, and then 1458. When you do that, you get 0.1504. And it did want it written as a percent. Remember, your calculator does not give answers to you as percents and does not deal with percent. So that's why we always have to convert things to decimals, or answers are given as decimals. So to convert this to a percent, we need to move our decimal point twice to the right. And so this is going to be 15.04%. Next section is 1.2, which is types of data. So the first two vocab words that we have are going to be parameter and statistic. So they're very similar if you look at the definitions. Parameter is a numerical measurement describing some characteristic of a population, whereas a statistic is a numerical measurement describing some characteristic, but this time of a sample. Remember, population is everybody, and a sample is that subset, that smaller group. So right below we have an example that says, suppose 67.3% of students at a college are taking at least one math course. This value represents a blank because something, and another blank there. So 60% of all students at a college. So since we're dealing with all students at a college, that's going to be a parameter. And this is because it is part of a population. All students is our population. The second part on here says, suppose we're sampling 100 students and 70.1% of them have at least one math course. This value represents a blank because blank. So this time we have a sample of 100 students. And so this is going to be a statistic. And this is because it is part of a sample. So 100 students is our sample. The next two vocab words that we have are going to be qualitative and quantitative. So qualitative or categorical data allow for classifications of individuals based on some characteristics. So maybe hair color, ethnicity, type of car, day of the week. You'll notice that those are usually not going to be any kind of numerical value or any kind of measurement. Whereas we have quantitative data, which provides numerical measurements of an individual like weights, heights, GPAs, and temps. So We have numerical and categorical is pretty much a way to think of these. And so the words that you need to know here, though, are going to be that qualitative and quantitative. So the example right below says classify the variables as qualitative or quantitative. And so the first one that we have is marital status. So this would be like single, married, divorced, widowed. And those are categories. So this is going to be our qualitative data. Part B says number of hours a student sleeps per day. So this is numerical. So this is going to be quantitative. Then we have part C, which is the cost of a new car, which is also numerical. So this is also going to be quantitative. And then part D says the number of on a basketball player's jersey. So if you think about the number that's on the back of their jersey, and we can just assume that this is going to be for a youth team, not professional, but that is numerical. However, those numbers do not represent anything. So this is actually a qualitative or categorical data. The reason why is because if you look at part B and part C, those numbers had some type of meaning to them. And so hours that you sleep per day or the cost of a new car, that can give you a number and you would have an understanding of what that number represents. Whereas if I say this is basketball player 78 and you're like, okay, I don't know what position they play or any team that they're on or anything like that, that number doesn't represent anything that is measurable or understanding. So the next two vocab words that we have are going to be discrete and continuous variables. And so a discrete variable is going to be a quantitative variable that has a finite or countable number of possible values, days of the week, number of students in a class, or pages in a book. So these are things you can literally count. And so countable is going to be a helpful thing there. It's also quantitative, which again, remember, is our numerical data with meaning. And then we have continuous variable. This is going to be our quantitative variable that has an infinite or not countable number of possible values. This is usually a measurement, so it's a good one to look at, such as times, temps, weights, and heights. So the reason why this is considered not countable is because if I say, what is the temperature outside right now? And you might say, oh, right now it's 75 degrees. But is it exactly 75? No, if you had a more accurate thermometer, you'd be able to measure that down to specifics. So maybe it's 75.8275306, and it could keep going on. Likewise, with your weight and with your height. Are you exactly your height? No. If you were to have a more precise measurement tool, then you'd be able to tell me exactly what you are down to millimeters and even farther down. So that is going to be our continuous data. So example right below says determine whether the variables are discrete, which again is countable, or continuous, which is that not countable or a measurement. So first one we have is A, and it says number of apps that you have on your phone. So you can count those. So this is going to be discrete. B says the length of a baseball game. And since we're talking about length here, that is a measurement of time. And so this is continuous. Reason why is, again, because usually when you say the game lasted an hour and a half, you can go even farther than just hours and minutes. You can go seconds, you can go nanoseconds, we can go break it apart even farther. Part C says temperatures in any random day in the city of Walnut. And so again, this is something that we would measure. We talked about temperature already, and so this is continuous. Part D says home runs hit by a baseball player, so we can count how many they actually hit. And so that would mean that this is discrete. And then the life expectancy of a person, this is dealing with age and a measurement. And so we're going to say this is continuous also. Again, because of that fact that it's a measurement, and you do not say that you are exactly 75 years old. You would say you would be 75 years old with so many months, so many days, so many hours, so many seconds, and again, we can keep breaking that down. The next part that we have is called level of measurement of a variable. And I'm going to draw an arrow here down the side, and this is going to be the way that we talk about it. And so the first thing is that a level of measurement of a variable, everything is considered nominal. And so nominal is going to be if the value of a variable, name, label, or category, in addition to the naming scheme, does not allow for the values of the variable to be arranged or ranked in any specific order. Everything is nominal. This is just going to be by default. And so we're going to go down this arrow that we wrote down on the side. The next thing we're going to check is to see if it's ordinal. So ordinal is going to be if the variable has the properties of nominal, however, the variable is arranged or can be ranked in some specific order. And we should say, and it makes sense. So it can be put in some type of order, like we can put dollar amounts in order, money amounts in order, we can put heights in order, we can put weights in order, and those all make sense. So it's going maybe from the shortest person to the tallest or vice versa. The next thing we have is interval, and this is going to be that the properties of the ordinal level of measurement are met. However, the differences in values of the variable have meaning. And so in math, differences mean you can subtract, and they make sense. So I can subtract dollar amounts, and that would tell you the difference between the values that we have, or maybe those two things cost. I can subtract weights, and that would tell me the difference between the two objects that I'm weighing. And so, but making sure that it makes sense. The next thing that we have is ratio. And so this is going to be if the variable has the properties of interval. However, it has a natural starting 0 point. And also, here's the big part, is going to be that the ratios of the values of the variable have meaning. So ratio for us here is going to mean dividing. And so for that, it does have to make sense. So you can divide those numbers, those ideas that we have for our variable, and it would make sense. So the example that's right below says determine the level of measurement of each variable. So the first one that we have is going to be birth year. And so the way that we are going to do this is I'm going to start at the top of that arrow and work my way down. So everything is nominal. I don't even check it. The next thing is a birth year. So if you guys think 2000, 2001, 2002, 2003, can you put them in order and it makes sense? Yes, I just did. I put them in the longest time ago to the most recent. And so definitely ordinal would work. So now I'm going to check and see if interval makes sense. So if I had, and I'm just going to pick 2 years, so I'm going to say 2000 and 2002. And it wants to say that you can have a difference. And remember, difference means subtraction. And so can you subtract 2000 and 2002 and it makes sense? Yes. If you were to subtract those, you would have 2002 minus 2000 and you would get 2. Well, that tells me there's a 2-year difference between those years. So yes, that makes sense. Now, the next thing is ratio. Can we divide them and it makes sense? So if you did 2002 divided by 2000, you do get a number. But does that number have any meaning? Not that I can think of. So that means it's not ratio. So that means the farthest that we went was interval. So the next one that we have is marital status. And so again, what marital status is going to be like single, married, divorced, widowed, and so forth. And so the first thing that we have on here is going to be nominal. Everything's nominal. The next thing is ordinal. Can you put them in some specific order and it makes sense for that data? So I don't know which one. I feel like you see that a lot on different applications and things, or forms that you have to fill out, but they're all written in different orders. Sometimes married is listed first, sometimes singles listed first. And yeah, I get that you can put it in alphabetical order, but that doesn't do anything for an understanding of the material. So can you put them in order, some specific order that makes sense for that data? No, you cannot. So this is an example of nominal, because I cannot put it in order to make it make sense. Since it's not ordinal, I don't go on any farther with this and checking interval or ratio, because it couldn't have that. So as soon as you find something that doesn't work, you just go with the one that it did work with. The next one that we have is the letter grade of all students in a statistics class. So this would be like A, B, C, D, and F. So that's our letter grades. I want you to realize that it does say letter grades. So it's not percentages. And so with letter grades, everything's nominal. The next thing is ordinal. Can you put them in some specific order and it makes sense? Yes, you can go from an A to an F, so it'll be the highest grade down to the lowest grade, or vice versa. So interval would be, can you subtract them and it makes sense? So what is an A minus an F? That has no meaning. And so it could not be interval. So that means the farthest that we were able to go was ordinal. Heights, part D, heights of K through 12 students. And so with heights, this is, let's say, just for example, let's say one student is 6 feet and the other student is 3 feet. So nominal is going to be, everything's nominal. So I'm going to go ahead and say, can you put heights in order and it makes sense for ordinal? And yes, you can go smallest, the shortest student to the tallest, or vice versa. Interval, can you subtract those heights and it makes sense? Yes, I can take your height and subtract it from another student's height and it makes sense. Or like the two students that I was pulling from our list of K through 12 students, someone was 6 feet, someone was 3 feet. If I subtract them, I can see there's a 3-foot difference. And then ratio is going to be that you can divide and it makes sense. So, and I picked nice numbers just to kind of show it a little bit cleaner, but I have a 6-foot student and a 3-foot student. So if you did 6 divided by 3, I get 2. But what does that 2 represent? That 2 tells me that the one student is twice as tall as the other student. So that has a meaning. And you can even divide out numbers that are not so nice. And maybe you would say, oh, he's 1.57 times taller than that other student. So this has a meaning. So this is an example of ratio. And that's one of the hardest concepts for students, I would say, for chapter 1 is the level of measurement. So it's definitely something you want to work on in our homework, and definitely reach out if you have any questions. Next thing that we have is going to be 1.3, which is collecting sample data. And so you'll notice that again we have a bunch of vocab words here. First one that we have is the response variable. This is the quantity that we are asking a question about. Next vocab word is a placebo. This is a harmless medication, like a sugar pill that looks, tastes, and smells just like the experimental medication. We have what's called the gold standard, which is randomization with the placebo treatment group. We have one of our big words here is going to be experiment. This is going to be a treatment is applied and then the effects are observed. So maybe you were given a trial drug to try to see if it would help with your asthma, or maybe with blood pressure or something like that. So you were given something and then we're going to see what the effects were. The individuals of the experiment are called an experimental unit, and they are often called a subject if they're people. The treatment, next vocab word, is the factors or exploratory variable, independent variable, that is manipulated by the experiment. We have a control group. This is a group of subjects or conditions that is matched as closely as possible in an experiment group, but is not exposed to the experimental treatment. So maybe they were testing that blood pressure medicine and you got it. However, that control group would have gotten a placebo, something that looks, tastes, and smells just like the other medication, but it doesn't have any effect on blood pressure. The next thing we have is called the placebo effect. This is going to be an individual subject believes that they are receiving a treatment when they're actually receiving just a water pill. And then we have observational study. So we have an experiment up above, which is where you were given something, whereas we have an observational study. This is where we observe and measure specific characteristics, but do not attempt to modify the individuals being studied. So you're not changing anything, you're just observing what's going on and what's happening. So, for example, if you were to be sitting and watching and seeing how many people actually stop at the stop sign at Mount Sac, it's not you doing anything, you're not putting anything out there, you're not asking them to do anything, you're just observing those outcomes. So the example right below says determine whether the study is an experiment or an observational study and identify a major problem with the study. So part A says, in a survey conducted by the USA Today, 1,465 internet users chose to respond to this question posted on the USA Today electronic edition. Is news online as satisfying as print and TV news? 52% responded yes. So really quick, they did not give anything to these people or anything in terms of treatment. And so this is going to be an observational study. And what is an issue with this? Well, they just asked people to respond. And so because of that, they weren't actually collecting data from everybody. They also did this in an electronic edition. So it's not even put on TV or in the print, which is the other forms of ways that they have given the news. So this is going to be a convenient sampling problem. Part B says an independent researcher tested the effects of a keto weight loss program by randomly selecting 1,000 subjects using that program. Each of the subjects was called to report their weight before the diet and after the diet. So this is an experiment. The reason why is because they were given a specific diet. So that treatment is going to be the keto diet. The issue here is going to be they're self-reporting their weights. Do you think everyone is being honest on this? Usually whenever anything is self-reported, we do have errors. So this is self-reported, and this is the problem. So right below this, we have more vocab words. And the first thing that we have is called blinding. And this is going to be a subject does not know if they're receiving a treatment or a placebo. We have double blinding experiments are going to be neither the experimental unit nor the researchers in contact with the experimental unit knows which treatment the experimental unit's giving. And the reason why they use this sometimes is maybe people react, the researcher who's in contact might react or behave differently if somebody's getting a placebo versus the actual treatment. We have replication. This is going to be the repetition of an experiment on more than one individual. Randomization is used when individuals are assigned to different groups through a process of random selection. And then we have our first type of sampling on here. And so this is called simple random sample, or SRS for short, so they'll abbreviate this. And this is going to be a subset of individuals. A sample are chosen from a larger set in of a population, and each individual of the subset has an equal probability of being chosen. So this would be randomly selecting people. So there is no bias, there is no selecting certain types of people or anything like that. Everybody is treated the same. And everybody's just as likely to be selected. And this is a simple random sample. So right below this, there is an example. It says, in the experiment in which blood pressure medication is tested, Group A is given the blood pressure medicine and Group B is given a placebo pill. The two groups do not know which medication that they were given. However, the researchers do know. So the first question says, what is the treatment? And the treatment's what was given, and this is going to be a blood pressure medication. It says, what is the control group? And this is going to be Group B. The reason why Group B is because they were given a placebo pill and not actually the medication. The last question on here says, what kind of blinding experiment is this? And it says that the researchers do know what medication that they were given, but the subjects do not. And because of this, we know that this is going to be blinding, or another way that they might write this is going to be single blinding, or just blinding. On the next page, there's another example that says the plant ginkgo biloba has been used in traditional medication for thousands of years. Doctors and researchers are collecting and want to figure out if ginkgo could be used to safely treat symptoms of dementia caused by Alzheimer's disease or multiple strokes. In this placebo-controlled single blinding experiment, 309 subjects were either given daily ginkgo extract or a placebo and were followed for the next 52 weeks. So the first part here, A, says, what does it mean for the experiment to be placebo-controlled? So what this would mean is that some of the subjects got a placebo. So some subjects got placebo, but others are actually going to get that ginkgo biloba extract. Part B says, what does it mean for the experiment to be single-blinded? And so this means that the subjects don't know what they got, but researchers do know. So subjects don't know, but researchers do. Know what they got. And again, they either got that ginkgo biloba extract or a placebo. Part C says, what is the population for which this study applies? And what is the sample? So your population is going to be adults with dementia caused by Alzheimer's. So we'll say adults with dementia caused by Alzheimer's or multiple strokes. In our sample, they collected data from 309 adults with dementia caused by Alzheimer's or multiple strokes. What is the treatment? So you want to make sure you're very specific with this for Part D. And so our treatment's going to be daily. It wasn't given twice a day, every week. You want to make sure you're specific with this. And it was ginkgo biloba extract. And how long was it given for? So it was given for 52 weeks. Part E says, what is the response variable? Is it quantitative or qualitative? And so the response variable of what they're trying to do is treating symptoms of dementia. And this treatment, we do not have any kind of numerical method we can give it, so that we would assume that this would be qualitative or categorical, saying maybe they passed it, they didn't pass it. The next thing that we have down here is going to be stratified sample. And this is going to be where you're separating the population into non-overlapping, mutually exclusive groups called strata, and then obtaining a simple random sample from each stratum. The individuals in each stratum should be homogeneous or similar in some way. The benefits of this over simple random sampling are that this may allow fewer individuals to be surveyed, yet obtaining the same or more information. An advantage of this type of sampling, the stratified sampling, is to determine characteristics within each stratum. So example right below says Walnut High School's ASB wants to determine the student's opinion on a recent assembly. They divide the school into grade level groups. What are the different stratums for this survey? So the different grade levels are going to be our different groups or stratums that we have. And so we have freshmen or ninth graders, sophomores, or 10th graders, juniors, our 11th graders, and then seniors, our 12th graders. So we have 4 groups or 4 stratums here. Next type of sampling that we have is systematic sampling right below. And so a systematic sampling, this is attained by selecting every kth individual from the population. The first individual selected corresponds to a random number selected between 1 and k. The benefit of this is that it doesn't require a frame, so you don't have to list the individuals in the population. And so we have an example. The example says a local hardware store decided to survey every 5th person. So it's every 5th person that leaves the store. The owner randomly selects the number between 1 and 5, and let's say 3. And it says determine which customers they survey. So they're starting with the 3rd person. And so that 3rd person is the first one that they're going to be surveying. And then they're going to go every 5th person. So we're going to add, and I'll write it down here, plus 5. And so we get 8. And if we add 5 again, we're going to get 8 plus 5 would be 13. So the 13th person that leaves, they'll survey. If they add 5 again, they're going to survey the 18th person that leaves. And this process could keep going. We'll do one more. So if you do 18 plus 5, you do get 23. And I'm just going to put dot, dot, dot. They'll continue this process until they feel they have enough data, or maybe till the end of the day. The next type of sampling that we have is called cluster sampling, and this is dividing a population into sections or clusters and then randomly selecting some clusters, choosing all members from that selected cluster. So a lot of students get confused with cluster and also with our stratified sampling that was up above on the previous page. So the difference is going to be clusters, just putting them in groups. They don't have to be similar in any way. It's just like find a partner, and it would just be that way. Whereas stratified means you have to find somebody maybe that's the same major as you, or the same birth month as you, or something where you have some kind of similarity between the groups. The last type that we have down here is called convenient sampling, and this is going to be as a sample in which individuals are easily obtained, self-selected, and not based on randomness. For example, phone-in polling, internet surveys, solicitors at a store. These results are unreliable. So determining the sample size is key in the overall statistical process. Researchers need to know how many individuals they need to survey. in order to draw some type of conclusion about the population from its findings. Realistically, the main determining factors of sample size or of an experiment are going to be determined by the amount of time that that group has to collect data and also the money that they have in order to conduct the research. And so this is all talked about in chapter 7. So we have an example right below that's going to talk about the different types of sampling. And it says, assume that the population consists of all students currently in your statistics class. For simplicity, we're just going to say we have 36 students. Describe how to obtain a sample of 6 students. So we just want a sample of 6 students so that the results of the sample are the given types. So part A says it's a simple random sample. So in order to do this, I might take a hat and take everyone's names, cut them up and put everyone's names on a little piece of paper and put them in the hat and randomly draw 6 people. So I'm just going to randomly select 6 people. Another way that we could do this is maybe put everyone's names on popsicle sticks and just randomly grab 6 popsicle sticks, and those would be my 6 volunteers that I needed. Part B says a systematic sample, and so this is going to be selecting every certain person, and so I'm going to say let's select every 6th person that enters the class. And we'll assume everybody's showing up to class that day. Part C says stratified sampling. And again, remember the stratified is dividing into groups, and the groups need to have something in common. So why don't we divide into, let's do 3 groups. And there's so many different ways to group things. You can group based upon ethnicity, you can do groups based upon major, you can do groups based upon age, but I'm going to say let's divide groups. And let's say 3 groups. And our groups are going to be based upon political affiliation. And so we're going to say either Democratic, Republican, or we'll say everybody else will just put together into an independent group. So from here, we're going to select, because remember we needed 6 students total, and so I'm going to take a little bit from each group. So I'm going to take 2 from each group because that would total to 6 that I need. So I'm going to say and select 2 students randomly from each group. Or each, remember another way to say group would be stratum. So the next thing that we have is going to be a cluster sample. So this is going to be where we just divide people into groups, and it doesn't have to have any kind of similarity between those. So let's say we have students get in pairs. We'll say groups of 2. So you find a partner to work with. So again, we need 6 people total. And so you're going to select groups and select everybody from that group. So we're going to select 3 groups. So you're selecting 3 groups of 2. Select 3 groups and include everyone from that group. So that means you pick 3 groups, and so you're going to have those partners, the next group partners, and the next group partners. The last one that we have here is E, which is convenience sampling. And the easiest way to do this is just ask for volunteers. So ask students to raise a hand. might be students email me if you're interested, something like that, where it's just convenience. You have a choice. You can either respond or not respond. So the example right below says determine the type of sampling that is used. So part A says the author collected sample data by randomly selecting 5 books from each of the categories science, fiction, and history. The number of pages of the books were then identified. So we group these by science, fiction, and history. So this is by the type of book that we have. And then they selected 5 books randomly from each of those groups, from each of those categories. So 5 science, 5 fiction, and 5 history, and then they record the number of those books. So since we have those groups where they have a homogeneous, they have something in common with one another, this is going to be stratified sampling. Part B says during the last presidential election, CNN conducted an exit poll in which specific polling stations were randomly selected and all voters were surveyed as they left the premises. So since they had them grouped by polling station, people could have different political affiliations, everything. So from there, though, they selected all voters and they surveyed them as they left that premises. So not just a couple from each one, but everybody from that. So this is going to be an example of cluster sampling. The last page here, we have some more vocab words. And so reading through these, we have completely randomized design. This is going to be each experimental unit is randomly assigned a treatment. We have matched pairs design, which we see a lot more in later in some of our chapters. And this is going to be an experimental design in which the experimental units are paired up. The pairs are selected so that they are related in some way. There are 2 levels of treatments in a matched pairs design, usually before and after or with twins. We have a randomized block design. This is used when the experimental unit is divided into homogeneous groups called blocks. Within each block, the experimental units are randomly assigned a treatment. Non-sampling errors result from undercoverage, non-response bias, response bias, and data entry errors. Sampling errors are going to result from using a sample to estimate information about a population. This type of error occurs because a sample gives incomplete information about a population. We have non-random sampling errors, and these are the results of using a sampling method that is not random, such as using a convenient sampling or voluntary response sample. So your chapter 1 notes should be complete. So you want to make sure that you save them if you're using a tablet or scan them in as a PDF, but they need to be a single PDF. This means one file, not 7 separate ones for each page. And then you need to upload this onto Canvas. If you have any questions, please stop by during office hours or email me and let me know. Also, check the resources on Canvas about how to successfully upload and post your solutions onto Canvas for your notes to get credit. Great job. Keep up the great work.